Myself, Dr. Basir-Ahamed-Khan, Department of Physics, Krishnath College. This is the second lecture of Module 5 on beta and gamma function. Now, I will discuss two topics in beta and gamma function chapter. One is expressions of integrals in terms of gamma function, and second is error function or probability integral. Now, before going to the expression of integrals in terms of gamma function, I just introduce some standard value of beta and gamma function. We already know in my previous lecture that beta mn, the definition of beta function, beta mn equal to integration over 0 to 1 x to the power m minus 1 into 1 minus x whole to the power n minus 1 dx. This is the definition of beta function, where m and n, two parameters, are greater than 0. The second equation is beta mn equal to beta nm. That means if I interchange n and m, the value will be the same. The third equation is the another form of beta function, which is represented by polar coordinate. That means this value is equal to 2 times 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power 2n minus 1 theta d theta. This is the another form of beta function. Now, gamma function, gamma n, is represented as integration over 0 to infinity e to the power minus x to the power n minus 1 into dx. And lastly, the relation between gamma function and beta function. Now, beta mn equal to gamma m, gamma n divided by gamma m plus n. Now, before going to the expression of integrals, I use this definition of beta function. Here 2 times 0 to pi by 2 cos to the power 2m minus 1 theta sine to the power 2n minus 1 theta d theta equal to beta mn equal to gamma m, gamma n divided by gamma m plus n. Therefore, this integral equal to gamma m, gamma n divided by 2 times gamma m plus n. That means half beta mn. Then this integral can be written as integration over 0 to pi by 2 sine to the power p theta cos to the power q theta d theta equal to half of beta p plus 1 divided by 2 comma q plus 1 by 2. This is another form of beta function. That means we get 0 to pi by 2 sine p theta cos q theta d theta equal to half beta p plus 1 by 2 comma q plus 1 by 2. These equations comes from this equation, where I just put 2m minus 1 equal to p. That means m equal to p plus 1 by 2, p plus 1 by 2, and 2n minus 1 equal to q. Just I replace 2n minus 1 equal to q, then we get n equal to q plus 1 divided by 2. This is the, this this is the another form of beta function. I use this relation in future. Mathematical this mathematical relation is I will used this mathematical relation. Now I will show you some another form 0 to pi by 2, sorry, 0 to pi by 2, 0 to pi by 2, this becomes 0 to pi by 2 sine to the power n sine to the power p x cos to the power qx dx equal to gamma p plus 1 by 2 gamma q plus 1 by 2 divided by 2 times gamma p plus q plus 2 divided by 2. If case 1 if q equal to 0 and p equal to n, then this equation becomes 0 to pi by 2 sine to the power n x dx equal to gamma n plus 1 divided by 2 or gamma n plus 2 by 2 into root over of pi by 2, root over of pi by 2, because gamma half equal to root over root pi. Case 2 if I take p equal to q, p equal to 0 and q equal to n, then we will get the same result for cos to the power n x dx equal to gamma n plus 1 divided by 2 divided by gamma n plus 2 by 2 into root over of pi by 2, root over of pi by 2, root over of pi by 2. I use this relation in the next problem. Now my topic was the expression of integral in terms of gamma function. Now a problem: express express the integral 0 to 1 dx root over of 1 minus x to the power 4 in terms of gamma function, in terms of gamma function, in terms of gamma function, in terms of gamma function. The answer is, I have to express this integral 0 to 1 dx 1 minus x to the power 4 in terms of gamma function. Now I put x square equal to sine theta, then x equal to, that is x equal to root over of sine theta. So dx equal to half sine to the power minus half theta into cos theta into d theta. Therefore, this integral becomes 0 to 1 dx root over of 1 minus x to the power 4 equal to 0 to pi by 2, 0 to pi by 2, because here when x and theta, when x equal to 0, theta equal to 0, when x equal to 1, this is pi by 2. So 0 to pi by 2 into half sine to the power minus half theta into cos theta into d theta divided by root over of 1 minus sine square theta, 1 minus sine square theta. This equation I write this half, just I put half in the left side of the integral 0 to pi by 2, this and this the same, and we get sine to the power minus half theta d theta. Now this is very similar, this equation is very similar, this equation 1 is very similar to this equation, this is very similar to this equation. Therefore I put the value here n equal to minus half, then it will becomes half into root pi by 2 into gamma half minus half plus 1 divided by 2 into gamma minus half plus 2 by 2 equal to root pi by 4 into gamma 1/4 divided by gamma 3/4, gamma 3/4. This is the form of gamma function of this integral 0 to 1 dx root over of 1 minus x to the power 4. This is the required result. This is the required result. This is the required result. Now another example. Now express the integral, 0 to 1 0 to pi by 2, 0 to pi by 2 root over of tan theta d theta, root over of tan theta d theta in terms of gamma function, So first of all I have to express the integral 0 to pi by 2 root over of tan theta d theta in terms of gamma function. Here 0 to pi by 2 tan theta root over of tan theta d theta equal to 0 to pi by 2 sin to the power half theta cos to the power minus half theta d theta, and this equation 2 is very similar to this equation, this is very similar to this equation where p equal to half and q equal to minus half. If I put p equal to half and q equal to minus half, then I will get the value of this integral. So therefore this equal to gamma half plus 1 divided by 2 into gamma minus half plus 1 divided by 2, and in the denominator 2 gamma half minus half plus 2 divided by 2 equal to gamma 3/4 and into gamma 1/4 divided by 2 gamma 1. This is half gamma 1/4 into gamma 3/4. This is the required result. This is the required result. This is the required result. Now I will go to the next topic, error function or probability integral. Error function, error function, error function or probability integral. Probability integral. Probability integral. The error function is defined as error function is defined as ERF, error function of x, equal to 2y root over of pi 0 to x e to the power minus t square into dt. This is the definition of error function. This integral arises in the solution of certain partial differential equation of applied mathematics and occupies an important position in the probability theory. That's why it is also called probability integral. Now the definition of complementary error function. The complementary error function is defined as complementary error function is defined as complementary error function is defined as error function is defined as ERFC. Complementary error function is defined as complementary error function x equal to 1 minus error function of x. This is the definition of complementary error function. Now the properties of error function. Properties of error function. Properties of error function. Properties of error function. First properties of error function is error function of minus x equal to minus error function of x. It is very easy to show these properties. You have to just put the value of minus x, value of x into minus x, and you will get this result. The second property is, because we know that error function of x equal to 2 by root pi integration over 0 to x e to the power minus t square into dt. If we put x minus x, if we put x into minus x, then you will get the properties 1. Second property is error function of 0 equal to 0. It is obvious, because if we put error function of x equal to 2 by root pi 0 to x e to the power minus t square dt. Here if we put x equal to 0, then error function of x, error function of 0 equal to 2y root pi 0 to 0 e to the power minus t square dt will give you the 0 value. This is the second relation. Third relation is third properties of error function is error function infinity equal to 2y root pi 0 to infinity e to the power minus t square dt equal to 2y root pi into root over of pi by 2, because we know that the value of this integral is root over of pi by 2, and we will get this equal to 1. This is the third property.